In today's video, we will be learning about what prime numbers are. So a number is prime if it is a natural number. So 1, 2, 3, 4, so on and so forth, basically any number but 0, and is divisible by exactly two natural numbers. So either the number 1 and itself. So divisible by exactly 2 by exactly two natural numbers, one being itself and the other one being 1. And it might sound a little confusing, but once we get into some examples, it'll make a lot more sense. So let's just go ahead and jump right into it. We'll start with the smallest number we know, which is the number 1. And it's the number 1, when we look at it, the number 1 we can say, well, it's divisible by 1, so that's a natural number, and it's also by itself. So, but remember, it says it has to be exactly 2. So 1 is just one number. So this will actually be the only exception of not a prime number. And you'll see what I mean in a little bit. So let's move on to the number 2. And 2 is divisible by 1. And it's also divisible by itself. So that makes it two natural numbers. And so now we know that it is prime. And I'm going to go ahead and circle the numbers that are prime so that we kind of keep it in mind and can keep a track of them. And something to note is that 2 is the only even number that will be prime. Almost all odd numbers are prime, except for the number 1, of course. So now we move on to 3. And 3 is divisible by 1 and divisible by 3. Anything in between, so we know that 3 is also a prime number. And if we look at 4, of course, 4 is divisible by 1, and it's divisible by itself. However, 4 can also be divided by 2. So since that makes 3 natural numbers, 4 is not a prime number. And if we move on to 5, we know that it is divisible by 1. It's not divisible by 2 or 3 or 4, but it is by 5. So just 1 and itself, both natural numbers. So 5 will be a prime number. If we try number 6, we know that 6 is divisible by more than 2 natural numbers, so it's not a prime. And those numbers would be 1, 2, 3, and 6. So that's a lot more than just 2 natural numbers. So let's go ahead and move on to 7. And 7 is divisible by 1, but not 2, 3, 4, or 5, or 6, but it is divisible by 7. So yes, 7 would make a prime number. And I'm sure you're starting to see a pattern now of the numbers that are not prime have more than 2 natural numbers that it can be divisible by. But the best way to really think about prime numbers is to see them as building blocks that you can't break down any further. So if we look at the number 6, we can break it down into 1 times 6 and 2 times 3, and that was able to be broken down. But if we look at the number 7, there's no other factors that we can break down. But what if we move on to bigger numbers? Let's say 16. Obviously, we know that 1 and 16 make 16. But we can see if there are any other factors that can also go into 16. So we can move on and say 2. And we know that 2 and 8 make 16. And 4 times 4 makes 16. That is a lot of different factors going on, which would obviously mean that 16 is not a prime number. But what about 17? We know that 1 and 17 go into each other. 2 and nothing else, which would make 17 a prime number. But what if I give you guys a hard one? Let's go ahead and try a difficult number. Let's say 51. And feel free to pause the video to see if anything other than 1 and 51 go into 51. But I'm going to give you the answer anyway. So you might think this is kind of tough. You know, we've got 2 odd numbers, so it must be prime because odd numbers are prime. However, if you go down the factor line, 2 times nothing equals 51, but 3 times 17 does equal 51. So 51 would actually not be a prime number.